The next experiment we're going to be doing is determining the value for molar volume. And before we get started on this lab, we're going to have to do a little bit of pre-work because of the equipment that we have. Normally you would use a gas tube, but we don't have a gas tube, so we're going to make do with a burette. Now, the problem with the burette is that we're going to be collecting gas most of the length of this tube. The problem is we only have graduations to here. So what you need to do, first of all, is very carefully fill this much of the burette with water, making sure you're looking at the bottom of the meniscus here, and you're going to empty this into a small graduated cylinder. Okay? Horizontal is closed, vertical is open. You're going to read this graduated cylinder. If you get the small ones, okay, you'll be able to read to 1/100th of a milliliter. Now, I would do that about 3 times and average them, because we need to accurately determine the volume of this unmarked section of the burette. Okay? Now, what you'll be doing with this experiment is you'll be taking a little piece of magnesium and you're going to be reacting it with some pretty concentrated hydrochloric acid. We're going to be using 6 molar. You're going to fill this burette with water. Well, actually, we're going to put the acid in first that you need, and you're going to finish filling it with water. You're going to encase your magnesium in this little copper netting of some sort. Okay? And this is going to be filled with acid in the bottom, water clear up here at the top. You're going to insert this. Put a stopper, and it's going to be a stopper with a hole, because as the gas is generated, it's going to displace the water. The water has to have some place to come out. Okay? Now, the acid is pretty dense, and it's going to be laying here in the bottom. We'll put that in first. Now, we're ready to react. And instead of using the 600 milliliter beaker, we're going to be using a very tall graduated cylinder. That's going to be filled with water. And what we're going to do is we're going to invert this into this cylinder like so. We're going to be able to actually see the acid draining down this tube. And you'll see when it comes in contact with your magnesium ribbon in your wire cage. Now, why doesn't the wire cage disappear? Well, let's think about your activity series. Where is copper, magnesium, and hydrogen related to each other on the activity series? Okay? Now, when the reaction's finished, you'll know the reaction's finished because you won't see your magnesium in this copper netting anymore. It'll be gone. Okay? Now, here comes the tricky part. We have to lift this tube until the water level in the inside tube matches up with the water level in the big graduated cylinder. Because when the 2 water levels are equal, that means that the pressure inside this tube is going to equal to the pressure in the classroom that day. And we'll be recording the pressure in the classroom that day. So we need to adjust this, and you're going to have to work closely, and a couple of you probably will want to look at it. Both of you in your lab group will want to look at it to make sure you agree on what the measurement in this tube is. Now, you have to use a little bit of problem solving to figure out the volume of the gas. Okay? Oh, we got a hi, Mommy, so time out. Time out. Okay, we're back. Now, you're going to do a little bit of math. Remember that this burette, the 0's down here, the 50 is up here. So you need to figure out the volume of gas between wherever the gas line is here to the 50, and then you have to add on that little bit of volume up here that you predetermined what that volume would be. That's going to represent the total volume of your wet gas. And why do we call it wet gas? Because we collected this hydrogen by displacing water, and there's going to be a certain amount of water vapor also with this hydrogen gas. But you know how to fix that using Dalton's law of partial pressures. Okay? Alright, so just to recap, what you need to do first, determine the volume of this burette. Now, so you make sure you get the same burette the next day once you mark it with a Post-it note. So you get the same one that you used, just in case they aren't all exactly the same. Alright, determine this volume. Then when we do the lab, measure your mass of magnesium, make your copper wire cage, and you'll be ready to roll.